Let's have a look at the graph of y equals cosine x. Sometimes you see these graphs as y equals cosine theta as well. So if it was y equals cosine theta, this axis here would be theta, this would be y. The axis up here. But since it's x and y, because y equals cosine x. Right, the cosine of 0 degrees is 1, hence we've got the point there 0, 1. And we know that this graph, unlike the sine graph, starts on the axis. Okay, so it starts at that 0, 1, whereas the cosine graph starts at the origin, because the sine of 0 is 0. So a different starting point here. But hopefully you've already watched the video on sine x, because we've got the period here of being 2 pi, that's the same. As you can see, one full wave from there through to there. Okay, that's 2 pi. 0 there to 2 pi there. The amplitude, that is distance between the middle and the top of the wave, okay, up to there is 1. And you can see it there as well. Okay, so that's the basic features of the cosine graph. Its maximum, minimum, both at 1 and -1. Its intercepts there are pi on 2, 3 pi on 2, neg pi on 2, neg 3 pi on 2. Next up we have y equals 2 cos x. That's the equation for that one. Now, because the coefficient of the cosine x is 2, we've now got an amplitude of 2. So you can see the graph goes up to 2. If it was y equals 3 cos x, that would be 3, and so on. So there's our amplitude, just between the middle of the wave and the maximum or minimum. Its period is still 2 pi, that hasn't changed. Okay, so for one full wave is 2 pi. But you see, it's what has changed is its amplitude. If I paste on the graph of y equals cosine x, you can see that there. Put that there. It's dilated by a factor of 2. Dilated by a factor of 2 from the x-axis. Okay, so any point on the original graph is taken twice as far away. Cosine 2x, the amplitude won't change. Okay, the amplitude is still going to be 1. Okay, distance between the middle of the graph and the maximum, that's still 1. What has changed is the period. We know we've got our formula, period equals 2 pi over n. So here, period would be 2 pi over 2, because remember, n is defined as the number in front of the x, the coefficient of x. So that means the period here would be pi. Okay, so one full wave this time. See that quite clearly. One full wave, the period is pi. Go there again, it's pi, whichever way you look at it. And if we compare it with the original graph, which I'll put over the top, you can see there how we've got our dilation by a factor of a half, okay, from the y-axis. So it's actually been brought in halfway to the y-axis from what it was previously. Okay, so that's the graph of y equals cos 2x. Y equals a graph of neg cos x. Okay, you can see it's been reflected in the x-axis. Once again, if I layer on top the original graph, you'll be able to see that quite clearly. Okay, there's the original graph, and it's been reflected. Oops, hold on, just a moment. In fact, the graph that I've drawn there, ladies and gentlemen, is not minus cos x. I've actually forgotten to change the period there, but that's alright. The graph here is actually the graph of minus cos 2x. Sorry about that. So I've taken the previous graph of cos 2x and I reflected in the x-axis. Anyway, you get the idea. It's turned upside down. Okay, it's a reflection in the x-axis. Once again, pointing out the tricky graph is y equals cosine 3x. Why is it tricky? Because the intercepts and maximums and minimums are fairly tricky. And the period here is going to be 2 pi over n, and n here is 2 pi, n here is 3, so it's 2 pi over 3. So that is our period, or the distance between one full wave. I'll now draw the graph, and I'll come back in just a moment. Okay, here's a graph of y equals cos 3x, and I mentioned there before the period is 2 pi on 3. So you can see there the distance for one full wave. There is, a bit better, is 2 pi on 3. I've marked in some intercepts there too. Halfway between pi and pi on 3 is pi on 6. So see that one there, that's pi on 6. Halfway between pi on 3 and 2 pi on 3, that's pi on 2. Halfway between 2 pi on 3 and pi is 5 on 6. And halfway between pi and 4 pi on 3 is 7 pi on 6. Now how do you do that? Look, it's sometimes worth, in this pi, I call it the pi on 3 scenario, because it's a little bit tricky. It's worth converting all the points sometimes to pi on 6s. So now at 0 you've got pi on 6, that's 2 pi on 6. Then you've got 3 pi on 6, 4 pi on 6, 5 pi on 6, 6 pi on 6, and so on. Okay, so those small divisions there are all pi on 6s. Now, of course, you've got to cancel those down, but sometimes if you mark them in pencil or something as pi on 6s, it makes it easier to know what these points are. So that's a bit of a tricky one, the cos 3x. So that's an introduction to cosine graphs.